Hello everyone. Great to see you again. In this video, I will go through step by step how I did my electric foundry from a used refrigerant tank. This video is a bit longer than the previous one, but in this video, I tried to cover every single step that I made. To some extent, I hope this video can give you some great references. If you are planning to do something similar to my project, I do think this electrical kiln will be a great equipment for my DIY workshop. So let's get started. I have a 30 pounds or 13 kilograms used refrigerant tank that I got from a local vendor. And now, I have to cut it into two parts. One to use as a body and one to use as the lid for my kiln. Please make sure that you've emptied the tank before you cut it, even though most of the refrigerants are not flammable. As you can see in this video, the 30 pounds tank has a perfect size for my mini kiln, as the height of the tank matched the length of the fire brick. And I really like that. To cut the tank straight using the hand grinder is not difficult for me at all, as I'm not an expert in this. However, I think safety is the most important key here. Please make sure you wear protective equipment while doing this. I just used a hand file to smooth it out. And here, as you can see, I'm drilling a hole to feed my thermocouple in later from the top of the lid. The handles were welded, so I used a chisel to take it off. However, that left me an unappealing hole. But don't worry, I fixed it later. To make the kiln stand firmly, I need to make new leg for it. So I used 4 relatively big and strong bolts to create them. I am drilled 4 holes at the bottom of the tank and tight them in. By the way, a great tool here is the step drill bit. I have to admit that I love it. As you can see, I'll use it many times in this video for different tasks. So if you haven't got one at home, please get at least one of this. Here I am just tightening the bolts and nuts to make my kiln's legs. And that's it. Now we have new 4 legs for this mini kiln. As now our tank can stand firmly. Let's make the base for our kiln. To do this, I used refractory cement and a layer of ceramic fiber. Ceramic fiber is so great at withstanding heat and isolating heat. I will definitely use more of this in my future projects. The only thing about this ceramic fiber is that ceramic fiber may cause itching and irritation to skin and eyes by contact. So just make sure to be careful when you are dealing with it. I am just adding a thin layer of refractory cement. Then the ceramic fiber. Then another layer of refractory cement. And at the end, I flattened it with a relatively liquidly refractory cement. Okay, now, just let the base dry itself. In the meantime, let's move on and make the body part for the kiln. Here, as you can see, I am drawing a circle template. This template will help me to create a cylinder for my fire bricks. So, after calculating, I'll need 5 fire bricks to create this cylinder for this body part. And 3 of them I need to cut it in half. Cutting fire bricks with a wood saw is like cutting butter with a sharp knife. Very easy. So it only take me a while to cut the fire bricks into the shape that I want. In the next minute, is how I cut it, and how I assembled it, step by step. Hope this can help you in case you need to cut fire brick with a curve shape. Here, as I measured the heating element, I need to make 5 continuous loops to make the grooves for it. I used a round file tool to file down the grooves. And a chisel just worked great in this case. And here is the final result. It only took me literally 25 minutes to finish all of it. And I also drilled 2 holes, as you can see. One at the beginning, and one at the end of the groove to put the bolts through. These bolts will act as 2 electrodes of the elements. You will see later in this video. Next step is to assemble them all with the refractory cement. Again, if you see my last video, the belt clamp is also a great tool that I can use in many tasks. Please check them out in the description, if you want to buy a couple of them. Now, it's time to take a small break while waiting all of those refractories to dry, would you? It is delicious. To be honest with you, I just bought this cream waffle because of its metal container, but it's tasted not bad at all. Okay, back to our project. Here I am cutting 2 pieces of aluminum to create the handle for my controlling box. By using some small bolts and nuts, and some L-shaped brackets, I can now have 2 handles perfectly for my box. I also cut a square hole from the lid to hold my PID controller, as you are seeing in this video. A hand tool grinder is a perfect tool for this. And also, at the bottom of the box, I drilled 3 holes for my cables to run through. One for the power supply, one for the heating element, and one for the thermocouple. As you can see here, the step drill bit is so convenient in many tasks. I am just drilling 2 holes on the take to attach the controlling box handle to. I am not quite sure how to call this one, but let's just call it the ceramic knob. This knob will be the perfect piece to hold the electrode bolt of our heating element. Here I am drilling 2 holes on the body tank to put these knobs through, as these knobs will isolate electricity and heat from our heating element to our tank body. A 1-inch hinge is good enough for my mini kiln. But in addition, to prevent the lid from open too widely, I use 2 relatively long bolts when screw them on. So as you can see, my lid now can be opened at the right angle that I want. This is the high temperature resistant ceramic terminal connector. We will use this to connect the heating element to its power supply cables. This is just a normal hand lock that you can purchase at any hardware supply store. I will use this as the lock between the lid and the body of the kiln. I love it. Works great and looks great. Okay. Do you remember the hole on top of our lid? Let's fix it. I use these bolts, nuts, and washers to hold the ceramic fiber of the kiln lid. You will see in just a few minutes what I mean. In addition, I found this round knob is the perfect place for my lid handle. So I just drilled a hole right into the center of it, and attached my handle, as you see in the video. Looks great. Okay. Let's continue with ceramic fiber of the lid. Again, please be careful while dealing with this fiber. You don't want to feel itchy on your skin the whole day by touching it. Here I also cut a rectangular piece for my kiln body, that you will see after I'm done with the lid. I just simply used a duct tape to temporarily seal this hole, so I can put the ceramic fiber on, and pour the refractory cement on it. And as you can see here, these bolts, nuts and washer that I talked earlier, will help me holding the fiber nice and tight. I also drilled 5 holes at the rear of the lid, to hold the metal string. I just want to make sure that my lid is 100% secured. As you may find in this footage, there are 5 screws in the middle of the lid. These are for the thermocouple later. Here again, if you watched my last video of making the heat treat oven, I used the same 18 gauge Kanthal wire to make my heating element coil. But I do recommend 16 gauge if you can have them. To see more details of how to make it, please check out my other video. It's very simple and there are many ways to do it, and mine is just one of them. To put the element into the groove is straightforward and simple, since the element run as the spiral shape. Also, as you can see here, I use 2 long bolts as the electrodes of the heating element that I talked earlier. I've run the kiln in its max capacity, which is at 2192 degrees Fahrenheit or 1200 degrees Celsius. And don't worry, these bolts works perfectly. Here is what I suggest you not to do like me. That is to embed the heating element with the refractory cement, like I did in this footage. The consequences is that the heating element will get too hot at the sealing point, and will break at a certain point. Normally when the kiln reach 1800 degrees Fahrenheit, or 1000 degrees in Celsius. Instead, I found the best way is to use a stainless steel screw to hold it. This is the footage of my element after more than 10 times serving me at the temperature of 2192 degrees Fahrenheit, or 1200 Celsius. This might doesn't look pretty, but as this is the amendment after my mistake, I'm happy with its efficiency. Hope this will be a good reference for you project. Let's move on. Here I'm trying to fit both the fire bricks and the ceramic fiber in the tank body. It's a bit tricky though, but I finally managed to do it. My recommendation here is that you just put the fire bricks in first, and then tuck the ceramic fiber in later, as we actually don't need the ceramic fiber in one whole piece. Here you can see how the ceramic knob fit in nicely. This thermocouple is a bit too long for me this time, as I bought it as a spare when I made the heat treat oven. The good news is, you can easily cut off the wire inside the thermocouple. Just make sure to remember which wire is the positive one, and which is the negative one, as you don't want to screw it up by any means. These wires are quite hard, so be patient when you cut it. To put it back in, it is easy like changing a light bulb. Okay. Now let's get back to our lid as it already dry. Here I am drilling a hole to feed the thermocouple in, and 2 small holes beside it, to screw the thermocouple tightly. I also added some more refractory cement, just to make sure it is completely attached. Do you remember the 5 screws under the lid? Here is why and how I do it to hold the thermocouple from the inside. There's one problem here when I do it. As it dries, it will leave some cracks as you will see in the video. The reason is, I only used refractory cement. Pure cement is not stronger than cement and sand, known as concrete. As cement is only binding materials, which bind aggregate and sand with the help of water. So please add sand into this mixture when you do this or something similar to this. As you will see in my next video. I did learn from this project, and achieve quite decent results with the formula of 60% cement and 40% sand. Here is I'm just trying to fix it and make it smooth again. So far so good. Now it's time to make our tank look better. I just use a brass brush to brush all the old paint off. Here I am using 2 big washers, and attach them on 2 sides of the tank body, preventing the lid from moving sideways when I open and close it, protecting the hinge from getting damages in the long term. Alright. Now it is nice and tight. Okay. Our last job is to flatten the top of the kiln body with refractory cement, and make it smooth like my girlfriend's skin. You are right. Just rubbing it with a little bit off water, and it will be so smooth. I do the same for the lid. And also a little bit at the ceramic knob. I used high temp spray paint to paint my entire kiln. I actually painted 3 layers to make sure it gave a best matte black color on my kiln, and to protect it better. Here is the final look. I'm really happy with its color. Okay. Finally comes to the most tricky part, as I already succeeded in making my heat treat oven. Here I challenge myself to fit everything in this creamy waffle box, as I am already familiar with how to wire them. In case you need to know how to wire the PID controller, please check out my other videos. Since you might want to understand it clearer and better, I made it in a separate video for you. I did note a small adjustment in that video, so please make sure you read the description of that video. That adjustment will make your PID controller run like Usain Bolt in a long term. And finally here, after 27 minutes, we are connecting the controlling box to the kiln body. Thank you for staying with me until this point. It means a lot to me. So please, don't forget to subscribe my channel, if you want to see my other projects in building my own workshop for casting and crafting. For the thermocouple wire, as we open and close the lid frequently at the connecting point, I'm making a small spiral for it, to add some flexibility to it. And also, don't forget the alarm bell, as it is a great safety part of our kiln. And that's it. Now we have a whole brand new electric kiln for our workshop. Let's get it a test run. Please be noticed that the indicator of my PID is in Celsius. The red color digits indicate our current temperature inside the kiln. The green digits indicate our desired temperature. As soon as the temperature inside the kiln reaches the desired temperature, it will automatically stop the heating element from turning on. And as soon the temperature inside the kiln drops below 1 degree compares to the desired temperature, the PID will automatically turn the heating element on. You can adjust the dropping temperature until it turn back on in the setting. AL1 is to set the alarm. The green digits under indicate how many degrees you want to set the alarm. Here in the video, you see that I set in at number 5. This means as soon as the actual temperature inside the kiln goes above 5 degrees compared to the desired temperature, the alarm bell will go off. When the temperature inside the kiln comes back to normal temperature, the alarm will stop. I suggest to set the alarm at least 15 degrees difference, since the heating element will still remain hot for a few seconds, even if it was turned off by the PID controller. This makes the kiln will keep raising temperature for a while. And normally it will be 10 degrees in difference compared to our setting temperature. This kiln fits my 6.6 pounds, or 3 kilograms crucible. So that is actually more than enough. I am really happy with this project. And hope you like it too. Hope this project will give motivation on doing your own project. Please subscribe and check out my other and upcoming videos. See you in my next video.